Okay, for today's lesson, we're going to talk about area of kites and trapezoids. So starting off with the area formula for a trapezoid, it is 1/2 base 1 plus base 2 times our height. Okay, then looking at a kite will be something new for some of us. The formula for area of a kite is right here. 1/2 times diagonal 1 times diagonal 2. Okay, and remember, our diagonals, we have one diagonal that is short, and for this short diagonal, its pieces, its chunks are congruent. Okay, then we have our second diagonal, our long diagonal, and its pieces, its chunks are not congruent. Okay, that will kind of come into play as we progress in this unit, and I'll touch back on those 2 points towards the end of the lesson. Okay, let's take a look at number 1. I want us to find the area of trapezoid ABCD. Okay, so let's start with the formula for area. So area is 1/2 times base 1 plus base 2 times height. And let's ask ourselves, what parts of this formula are already provided for us in this picture? Well, the 1/2 is going to stay as 1/2. Base 1, yep, got that. Base 2, yep, got that. Height. I definitely don't have a height anywhere. Now, some of us may be able to recognize that segment AD is technically the height by definition. Starts at a vertex, ends at a base, forms a 90-degree angle. So AD is definitely the height. But do you have any way to calculate height of AD? Okay, no, we don't. So could I draw this height inside of my trapezoid somewhere that maybe would lend me a shape that I am familiar with, that I could find it? Okay, I could add the height in right here from the vertex of B down and form a right triangle. Okay, now, in order to find the height of this right triangle, I need at least one other piece provided me. I'm given the hypotenuse. Let's try to figure out what is this leg right here. Okay, now look at what we just cut our trapezoid into. We just cut our trapezoid into a rectangle, and this part of our rectangle was 11 feet. Okay, well, if this entire base was 16 and just this much of it is 11, how much of that 16 is left over right here? Okay, hopefully you're telling yourself 5. I can take my top base, which was 11, subtract it from my bottom base, which was 16, and my leftover is 5. Okay, so now I have 2 pieces of information provided me, and if I need to find the third, if I'm given 2 sides, asked to find the third, I can use Pythagorean theorem all day long to find that. Okay, so 5 squared plus that missing height that I need to find equals 13 squared. So 25 and 169. Subtract those and I get 144, take the square root of that, and we're getting our height to be 12. Okay, now at this point I think I have enough information to be able to plug into my area formula and solve. So area equals 1/2, my base 1 was 11, plus base 2, which was 16, times the height of 12. Okay, now you could technically type this all in the calculator, but we could logically work our way through it. 11 plus 16 is going to give us 27. Okay, then I always like to half my even value, so half of 12 is 6, and 6 times 27 is going to give me 162 feet squared. Okay, let's look at example 2 here. Example 2, they want us to find the exact area. That keyword of exact is letting us know that we better leave a radical in our answer if we have one in the problem. Okay, so again, I could start with the area formula. 1/2 base 1 plus base 2 times the height, and ask myself, what part of this formula am I already provided in the picture? Well, I'm definitely given base 1, and I'm definitely given base 2. But again, this height, they at least drew me my picture, but it's not labeled there. Okay, now, let's kind of use the same logic we did in example 1 on example 2. They already labeled my height in here. Looking at this, I have a 30, 60, 90 triangle, and I'm not given a single piece of it to help me find this height. Okay, now I do know that this top base is 9 and this bottom base is 19. Looking at example 1 to kind of help guide us, notice how we were able to draw in our height and cut our trapezoid into a nice pretty rectangle. This then allowed us to figure out, well, how much is left over if this much of it is used as a rectangle. Okay, so here's my height. It's cutting my trapezoid, but this doesn't look like a nice pretty rectangle. Okay, well, if they drew a height in here, couldn't I technically come over to this vertex and draw in another height over there? Okay, so now I have a nice pretty rectangle going on. This is 9, so by default, this piece of the rectangle would also be 9. So to figure out how much is left over for each of these chunks, I can take 19, subtract 9, gives me 10 left over, but I have to split that 10 evenly into 2 bases of this right triangle. So I can divide it by 2, and that tells me that each of these bases of the triangle, whichever one I want to use, is 5. Okay, now I'm focused in on just this right triangle right here that is a 30, 60, 90. Utilizing this 30, 60, 90, I can find my height. This would be considered my short leg. My height would be my long leg. I really don't need to mess with going from the short leg to the hypotenuse. That's just extra work. All I need to do is go from the short leg to the long leg by multiplying by the square root of 3. So my long leg, aka the height, is going to be 5 square roots of 3. Okay, now I have everything I need to find the area. So 1/2, my base 1 was 9, base 2 was 19. My height that I just found was 5 square roots of 3. Now, you can't just type this one into the calculator because they want an exact answer, aka our radical possibly in my answer. So we do have to logically think through the steps of this. So 1/2, 9 plus 19 is going to give me 28 times 5 square root of 3. I'm going to go ahead and take half of 28, which gives me 14. Still have that 5 square root of 3. Okay, and we've talked a lot about how values that are outside the radical can go ahead and be multiplied together. So 14 times 5 is going to give us 70 with a square root of 3 left over. Okay, and they didn't give us labels here, so I can just put units squared. Okay, let's look at another trapezoid problem, example 3. On example 3, they're telling us that the perimeter of an isosceles trapezoid, okay, I'm going to pause. An isosceles trapezoid is very similar to like an isosceles triangle, meaning 2 of my sides are going to be congruent. Well, these are my bases, they're not my sides, and they're clearly visibly not congruent. Okay, now these are my sides, so I could label them as congruent. Okay, let's continue reading. So it says the perimeter again of the isosceles trapezoid is 68 inches. The bases of this trapezoid are 32 and 16. And our job is to find the exact area. So again, I'm probably going to be having a radical in my answer, possibly. If I end up with a radical in the problem, it better end up in the final answer if need be. Okay, so again, if I start with the formula, it's always a good place to start to help us collect what we've already been given and what we need to find. I'm already given base 1. I'm already given base 2. Definitely not given the height though. I need to find that. So again, using the same logic that we've done on 1 and 2, looking at my height, can I essentially cut off the height and create a nice perfect rectangle? Okay, well, with what they have labeled so far, no, the rest of this is not a perfect rectangle. But I could draw in another height here, and now I've created myself a perfect rectangle. I can take that top base of 16 and subtract it from the bottom, which gives me 16 left over that has to be divided evenly into the 2 extra pieces here. So that leaves each of those to be 8. Okay, now looking at just one of my right triangles, so let me kind of highlight just one of these guys. So like looking at this right triangle, in order to even think about finding that height, I need to be given at least one more piece of information. I need to either be given another side, or I need to be given some sort of angle measure that alludes to a special right triangle. Okay, I definitely have no way to know, other than knowing that this one is 90, what these angles are. I wonder if there's a way for us to figure out what this side is. Okay, let's go back and read what they gave us. They told us that the overall perimeter was 68. Okay, we find perimeter by adding up all the sides, and I have 4 sides to my trapezoid. Okay, well, 2 of my sides are given, 16 and 32. If I add those together, I've already used up 40 of the total area, which leaves me with 20 left over to split evenly to the 2 congruent sides. Okay, again, here's my logic. There's the total area. I was given 16 and 32. I added them together. I used up 40 of the total 68, leaving me 20 that has to be split evenly into these 2 congruent sides. So that means each of my sides of my trapezoid are 10. Now back to this highlighted yellow right triangle. I'm now given 2 sides, asked to find the third. I can use Pythagorean theorem all day long. So 8 squared plus that unknown side that I need to find equals 10 squared. So I have 64 and 100. So x squared equals 36. So my overall height is 6. Okay, now I think we have enough to plug into our area formula. So 1/2, one of my bases was 16, one of them was 32, and we just found our height to be 6. Okay, so half of 16 plus 32 is giving us 48 times 6. Okay, half of 6 is 3 times 48 is giving us 144 inches squared. Okay, we're going to skip over 4 because it's very similar to 3, and let's go on to example 5 here. Back to Betty and her painting of her home. Okay, and this time they want us to find the area of her home. Again, we get to ignore that chimney, but this time using trapezoids. The other day when we were looking at it, we used a triangle and a rectangle. Okay, this time they're going to challenge you to use a different kind of shape. Okay, well, looking at this house, I could probably cut it down the middle and create 2 trapezoids. Let me highlight them for you. So I have a trapezoid here and a trapezoid here, both right trapezoids. Okay, let's just focus in on one of them for now. Let's focus in on this green one over here, trapezoid 1. So this guy. Okay, now it may benefit you to like turn your paper, so I'm going to go ahead and turn my paper so I don't get freaked out. Okay, so I've turned my paper, so then I'm looking at it kind of like we would normally look at a trapezoid. Okay, so looking at this green trapezoid here, I know that this top base is 15. They've labeled that for me. What is this bottom base? What is this one going to be? Okay, well, they told us that the overall height of the house was 30. So if I really just visualize bringing this in, then I know that this base down here is 30. Okay, so I have 2 bases. Now let's check and see, are we given a height? Well, if I said that this was a right trapezoid, that means that my height is here by definition. Okay, well, the entire distance from this to this, they told us, was 20. So if I'm only using this much of it, I'm only using 10 inches of it for the height. Okay, so now I think I have enough pieces of information labeled in this picture. I know base 1, 15, base 2, 30, height 10. Okay, so I'm going to flip my paper back around so we can do some writing. Okay, now we're back to normal. Let's take a look at this and write out what we've got. So we're finding the area of trapezoid 1. Okay, and that equaled 1/2 times, we said our top base was 15, bottom base was 30, and our height was 10. Okay, so 1/2 times 15 plus 30 gives us 45 times 10. Half of 10 is 5, and 5 times 45 gives us 225. Okay, so the area of just that green trapezoid, just this guy right here, was 225. Well, now I have a second one labeled here with the exact same dimensions. Okay, how do I know that? Well, I already knew that the height of this guy was 10. It was half of the total, so this height's going to be 10. And I knew this base was 15, so that means this base over here is also 15. And they shared this common base here, which was 30. So I already know the area of this yellow trapezoid too. It's also 225. So if I want to find the total area of the house, I can take 225 and add it to another 225 to give me a total area of 450 inches squared. Okay. Now on this guy, this is super similar to that one we did the other day. I'm not going to necessarily walk through the whole thing, but let's talk through it. It says that she now replicates this house 3 times on the canvas that is 30 by 100, and they want to know how much was not painted. Okay, well, we could start by finding the overall area of this rectangular canvas, multiplying those. And we just found that the area of a single house was 450, and there are 3 of them. So we could add all of these areas together to find out the total area that has been painted and subtract it from the total canvas. Okay, let's go ahead and move on to kites. So example 6, they want us to find the approximate area. Okay, that word approximate, if exact meant radicals, then approximate means that we can have a decimal in our answer. So they want us to find the approximate area of kite FLAG below if GF is 5, MF is 4, and AL is 15. Okay, at the very beginning, I gave us some little facts about kites. The first fact that I gave us was that the area formula was 1/2 times diagonal 1 times diagonal 2. The second fact that I gave us involved both of these diagonals. I said one of them was the short, and the pieces of it were congruent. The other fact that I gave us was that one of them was the long diagonal, and the pieces of it were not congruent. Okay, so let's break down what that means. Okay, visually looking at this kite, I can definitely tell that diagonal FA would be considered the short diagonal. Okay, and if it's the short diagonal, and I know that MF is 4 inches, and I know the pieces are congruent, by default, MA would also be 4 inches. So I know the total diagonal, if I added them together, would be 8 inches. Okay, well, I have now found one piece of this area puzzle. Diagonal 1, let's say, is 8. Okay, now how could I find diagonal 2, the long diagonal? I know that the pieces of it are not congruent, so I'm going to have to rely on some other information that I know about kites. Well, kites are made up of 4 right triangles. So that means all of my right angles can be found here in the middle. Okay, if we're trying to find the pieces of diagonal GL, how could I do that utilizing my right triangles? Let's take a look at this triangle here. I'm given 2 sides and essentially asked to find the third. So I could use Pythagorean theorem. So I could do 4 squared plus that unknown side squared equals 5 squared. Okay, now, rather than going through all this math, I mean, we totally could, I'm going to tell you right now, x is 3. So my missing side is 3. 3, 4, and 5 are considered a special Pythagorean triple. If I'm given 5 and 4, by default, automatically my opposite side that I'm missing is 3. Let's say if I was given 3 and 4, and I needed to find the hypotenuse, well, if I'm given 3 and 4, by default, hypotenuse is always going to be 5. That is just a special Pythagorean triple. Okay, now, I found part of that diagonal, but now I need to find ML, the other part of the diagonal. Okay, again, taking a look at what I'm given for this right triangle. I'm given 2 sides and asked to find the third, so Pythagorean theorem, 4 squared plus that unknown side squared equals 15 squared. So I have 16 equals 225. 225 minus that 16 is going to give us 209. And they use that word approximate, so I don't have to worry about factor treeing 209, so I can just type that in the calculator, hit enter, and let's round to the hundredths place, so 14.46. Okay, so I know each piece of that long diagonal, so now I can add them together to know that the total of diagonal GL is 17.46. So I can take that and plug it right on into my formula. Okay, so half of 8 is 4 times 17.46 is going to give us 69.84 inches squared. Okay, we're going to roll on past example 7. It's just like 6. Let's look at example 8, and then we'll call it good for today. Okay, they want us to find diagonal 2 of the kite, in which diagonal 1 is 14 and the total area is 238. Okay, well, throughout this entire lesson, I have said that our first step should be essentially writing down the formula for the shape that they're talking about. So a kite is 1/2 diagonal 1 times diagonal 2. Okay, then our second step is always to evaluate, well, what have they given me that can already be plugged in? Well, they've given me the total area, so they've given me A to be 238. That 1/2 is definitely not changing, and they told me my diagonal 1 is 14. They wanted me to find diagonal 2, so I'm given everything I need. I don't have to do any additional work to get to my final answer. So this is just a multi-step equation solving for a variable. So half of 14 is 7. To get D2 by itself, I'm going to divide by 7. So diagonal 2 is going to equal 34 inches. Okay. That's the lesson for today. Let us know if you have any questions. Go ahead and get started on that homework.